Welcome to your first lecture in college algebra. So just as a quick reminder, you should take notes as you would in a normal lecture. Feel free to pause when you need to, rewind when you need to, and just remember that you're not expected to understand everything. In fact, you may not understand anything, which is fine, but do copy the notes down, and as you do this, think of questions you have and bring them to class. I will go over every single slide during class and answer any questions that you guys may have. So your main job is to try to understand this, copy the notes down, but more importantly, think of what you don't understand and come to class with questions. So let's start with section 1.1 entitled Functions. Here are some definitions. When the value of one variable is related to the value of a second variable, we have a relation. A relation is just a correspondence between two sets. For example, if we were looking at the relation of the name of a city and their basketball team, then we would have one relation as Los Angeles Lakers, another one as Phoenix Suns, another one as Los Angeles Clippers, and another one as the Utah Jazz. So a correspondence between two sets. The first input is the name of the city, and the output is the name of the basketball team. Another example, when the input is -3, output is 5. When the input is 2, output is 6. When the input is 4, output is 8. When the input is 5, the output is 9. Second definition, the domain of a relation is a set of all inputs of the relation. And the range is the set of all the outputs. So the inputs, this is the first element, the output is the second element. For example, in the case of the city and its basketball team, the domain is a set of all inputs. So that would be Los Angeles, Phoenix, and Utah. Sorry for the bad handwriting. It's going to get better as I write more. The range is their respective basketball teams. So we got the Lakers, go Lakers. We got the Suns. We got the Clips. And we got the Jazz. Second example, the domain is a set of all inputs. Inputs are the first elements of a set. So we have -3, 2, 4, and 5. So our domain is -3, 2, 4, and 5. These are all the inputs. The range is a set of all outputs. So that would be 5, 6, 8, and 9. Next definition. A function is a relation in which each element in the domain, or each input, corresponds to exactly one element in the range or output. So each input has exactly one output. So is a relation in the first example of function, the first example being the cities and their basketball team. So let's list this out. The Los Angeles Lakers. We got the Phoenix Suns. We have the Utah Jazz. But then LA actually has two basketball teams. We got the Lakers and we also have the Clippers. Now the definition says each input can have exactly one output. But because Los Angeles, the input has two different outputs, they have two basketball teams, this is not a relation. Or sorry, this is not a function. It is a relation, but that relation is not a function because Los Angeles has two outputs. Let's look at the second one. We have -3, 5, so the input of -3 corresponds to an output of 5. The input of 2 corresponds to an output of 6. The input of 4 corresponds to an output of 8. And the input of 5 corresponds to an output of 9. Each input has exactly one output, therefore, yes, this is a function. Now, what happens if we're given a graph instead of a set like this? So remember, the definition says that for every input, the input are the x values. These are your inputs. And the y values, these are your outputs. So the definition says each input can have exactly one output. So we use something called a vertical line test. And here's basically how you use this. You start drawing vertical lines on the graph, whatever graph you have. And you notice how many times does that vertical line intersect the graph. So here, in each case, it's going to intersect the graph one time, which means that this input, whatever this input is, has exactly one output. Same over here. This input has one output. Inputs are the x's, outputs are the y's. Same over here. If you draw a bunch of vertical lines, then every single input is going to have exactly one output because each vertical line intersects the graph only one time. But take a look at this example. If I draw a vertical line, then whatever this input is, we'll call this x, it has two different outputs. We got one y here and a second y there. So because this input has two outputs on the graph, this is not a function. Same thing over here. This input has 1, 2, and 3 outputs. An output is anytime an input has a value on the graph. So this input has 3 different outputs, therefore it is not a function. Here's some notation. For a function y equals f of x, the variable x is called the input. So the parentheses always contains the input. And whatever f of x equals to, this is the output. Now this is going to be really important and keep coming up over and over again. So I'm going to keep saying this over and over again. In function notation, the parentheses always contains the input, and the result is the output. The input, x, this is called the independent variable because we can make it be whatever we want it to be. But the output is a dependent variable because it depends on which input was chosen. So we can take any input we want, but the output depends on the input. I'll give you an example. We can pick any city, like I picked LA, but that's your input. I could pick any city I want to because that's my choice. So that's an independent variable. But the output, it depends on what city I chose. So if I chose LA, then my output has to be Lakers and Clippers. If I choose Phoenix, my output has to be Suns. If I choose Utah, my output has to be Jazz. If I pick New York, my output has to be the Knicks. So the input I can choose, but the output depends on the input that's chosen. So here's an example where we find the value of a function. Let's find f of 0. So f of 0, remember the parentheses contains the input. So the input is 0. And we take the input and we replace this input every time we see an x. So each of the x values, x is just a placeholder, and that placeholder gets replaced with whatever input we have. So every time you see an x, you're going to replace it with whatever input we are choosing. So f of 0, this equals to 3 times quantity 0 squared plus 2 times 0 minus 4. Now for proper notation, we're going to bring down f of 0 every single time. In the order of operations, which is PEMDAS, parentheses, exponents, multiply, divide, add, subtract, exponent always comes before multiplication and division. So I'm not going to multiply 3 times 0. I'm going to do the exponent first. 0 squared is 0 times 0, which is just going to be 0. So we get 3 times 0 plus 2 times 0 minus 4. Okay, bring the f of 0 down. 3 times 0 is 0, 2 times 0 is 0, we got minus 4. 0 plus 0 is 0, 0 minus 4 is negative 4. So f of 0 is equal to negative 4, which means the input is 0 and the output is negative 4. Okay, part B, we got f of negative 2. So once again, the parentheses contains the input, and the input replaces each x in the expression to the right. So every time I see an x now, I'm going to replace it with a negative 2. Okay, so bring the f of negative 2 down every time for proper notation. Now negative 2 squared, this equals to negative 2 times negative 2. And a negative times a negative is a positive. So negative 2 squared is actually a positive 4. That's negative 2 times negative 2. And do one thing at a time. So in that step, only do the exponent. Okay, so f of negative 2, this equals to 3 times 4, which is 12, 2 times negative 2, which is negative 4, minus 4. 12 minus 4 is 8, 8 minus 4 is 4. So we got f of negative 2 which is equal to 4. This means when our input is -2, our output is going to be 4. Okay, next example, we got f of 4. So we have 3 times 4 to the second power plus 2 times 4 minus 4. So do this one on your own, and we will go over that in class. Let's take a look at letter D. That's a little bit different, right? Because our input is no longer a number, it's a variable, it's -x. But that doesn't change the principle. The principle says every time we have an input, the x values in that expression get replaced with whatever the input is. So instead of 3x squared, I'm going to replace this x with this input. So that's going to give me 3 times -x squared. And notice only the x gets replaced. The exponent stays the same. I have another x. So every single x gets replaced with the input. So I'm going to replace that x with the -x. Why? Because our input is -x. So each x gets replaced with that input. And then we got the -4. The -4 is called a constant because there is no variable there. It's just a number that's never going to change. So if I simplify this, I have f of -x. -x to the second power is -x times -x. A negative times a negative is a positive. So this is 3x squared. 2 times -x is -2x. Positive times a negative is a negative. And we got -4. Okay, then part E, we have f of x plus 1. So this gets even more complicated because now our input is x plus 1. So remember, the parentheses contains the input. And whatever the input is, we are going to replace this input with each x value up here. So instead of 3x squared, the x gets replaced with the input, which is x plus 1. And then you got 2 times x. The x gets replaced with the input, which is x plus 1. And then we have -4. Okay, so this gives you 3. Whenever you have an expression squared, always write that out twice. If it's a number squared, like -2 squared, you can do that in your head. -2 times -2 is 4. But with expressions like x plus 1, we have to actually write that out twice. Okay, so now let's go through and simplify. When you multiply 3 times x plus 1 times x plus 1, it's always easier to FOIL that first. I'll do this on the side. If I have x plus 1 times x plus 1, when I FOIL, I'm taking the x and I'm multiplying it to each element of the second parenthesis. So x times x is x squared, x times 1 is x. I do the same thing with this one. 1 times x is 1x or x, and 1 times 1 is 1. And then I add my like terms. X plus x is going to be 2x. So this is x squared plus 2x plus 1. And then we got plus 2 times x plus 1 minus 4. Then I distribute the 3. So this gives me a 3x squared. 3 times 2x is going to be 6x. 3 times 1 is going to be 3. Okay, so once again, I replaced each of the x's with the input, which is the x plus 1. Then I FOIL this. I got x squared plus 2x plus 1. And then I multiplied each term in the parentheses by 3. That's called distribution. Then I have 2 times x, which is 2x. 2 times 1, which is 2. And then I have a -4. So we have a 3x squared. Then we have a 6x plus 2x, which is going to be an 8x. We have a 3 plus 2, which is 5. 5 minus 4, which is 1. So f of x plus 1 is going to be 3x to the second power plus 8x plus 1. Now, keeping this in mind, I want you guys to try letter F. I'll help you get started. We'll finish this in class. So f of x plus h, remember, the parentheses contains the input. And whatever the input is, that replaces each x on the right side. So we have 3 times, instead of x squared, it's going to be x plus h squared. Plus 2x, so it's going to be plus 2 times x plus h, and then we have a -4. So what I want you guys to do is I want you to do what we did here. Write this out twice and FOIL it. And then combine your like terms. Okay, we will go over that in class.